Atomically Good Cooking is filmed in front of a live studio audience.
Welcome to Atomically Good Cooking! Hello, and welcome to Atomically Good Cooking. I'm your host, Democritus.
And I'm your other host, John Dalton. Today we will be making some atomically good food with some of our chemical friends. Our first dish today is Democritus' own creation called the atom.
I found it myself. As you can see, it is just a yummy circle. I thought that atoms were invisible and infinite in size and shape, but boy was I wrong.
Yeah, he sure was wrong. I found that atoms had specific behaviors in terms of weight and measurement. I also found the law of partial pressures. I formed an atomic theory.
Wow, John Dalton, look at the time. You should be going now. On to our next dish. I'm not really sure how this one will work, but here to explain his dish is scientist Henry Becquerel!
Wow, thank you. It's a pleasure to be here. I already prepared my dish today. It's just in the oven warming up. It's done.
Wow, that looks like it's been in the oven for days. What happened?
It has been in the oven for days, and it's supposed to look like this.
This is supposed to represent how I discovered radioactivity in atoms.
The residue on the paper proves that atoms can be radioactive. How cool is that?
Very chemical.
You're supposed to have your phone.
Our next guest is here. I'm gonna go get him.
Okay, have fun.
Hey, what's up? Hello.
Wow, your famous physicist J.J. Thomson. I'm a huge fan.
Yeah, I get that a lot. I'm here to present my thing that's not really plum pudding.
It smells great. Can you explain your dish?
It's pretty straightforward. It explains that there are positively and negatively charged particles inside of an atom. The blueberries represent the negatively charged particles, or electrons, and the granola is the positively charged particles, or the protons.
That sounds pretty good, but it's not really plum pudding.
What is it?
Vanilla pudding. We can't all be chefs here.
But this is a cooking show. Never mind, I have to go to the bathroom.
Okay, anyway, I wonder where Democritus is. He's been gone for a while.
I don't know, I'm looking for him too.
Who are you?
I'm Ernest Rutherford. I was your student a couple years ago. We studied X-rays together.
Doesn't ring a bell.
Anyway, I'm here to present my dish, called the nucleus.
It's about the same mass as the atom itself, because I found that almost all the mass in an atom is in the nucleus.
Wow, chemical. Do you want to hear a joke?
Not really.
Okay, so two atoms are walking down the street one day, and one of them says to the other, "Hey, wait up a second. I think I lost an electron." The first atom replied, "Are you sure?" The second atom exclaimed, "Yes, I'm positive."
That's funny. Why don't you go find Democritus and tell him that joke?
Good idea.
Anyway, he's just salty because I found that his atomic theory was wrong. But whatever. Ah, looks like our next guest is here.
It's a pleasure to be here. It's a pleasure to be here.
This is James Chadwick.
What are we making today?
That depends. What did you bring?
I didn't bring anything. I came to fix the not really plum pudding. Something isn't right.
There is one more subatomic particle that needs to be represented. These represent the subatomic particles with no charge.
The neutrons.
These neutrons sure are yummy. Keep up the good work, Chadwick.
Okay, moving on. My good friend Milliken has just showed up. Get over here, Milliken!
Hey, you can call me Robert.
Whatever you say, Milliken. What did you make today?
I also didn't really make anything. I just wanted to see if the not really plum pudding was correct. I was a scientist that actually discovered the charge of electrons, and I want my findings to be correct. Seems to be in order. Carry on. I'm gonna get myself a bite of this atom.
Okay, you do that. I'm gonna try and find Thompson. He's my ride home.
Okay, bye.
Hey, bro. Niels Bohr is the name. Science is the game.
Hey, you here for the show?
You betcha. I brought my favorite plate of food, the Bohr model.
This is supposed to represent my theory that electrons move around the nucleus at a prescribed orbit.
Pretty cool, huh?
That is pretty cool. I'm guessing those are the electrons and the orbits. It's pretty nice, man.
Yeah, I know.
Very cool. I gotta get going. There's more science to discover.
See you later, bro.
Hello, my good fellow. Have you seen a cat nearby?
Holy chemistry! Your famed scientist Junior. What are you doing here?
I'm here to present my dessert. But back to the cat. Have you seen a cat?
No cat, but can you please present your dish?
I'm actually here to change your model. I found that it has an inaccuracy. I discovered that the nucleus doesn't have a specific spot. These little candies right here represent the protons. Granola represents the neutron.
And they just kind of, inhabit this space. They don't have like a set little place to go.
Wow. Thanks, bro. I didn't realize how wrong I was.
No problem. I also discovered the wave equation, which states that electrons move in waves and not particle leaps. And my cat in a box theory.
That's all the time we have for today. Tune in next week for another installment of Atomically Good Cooking!
I'm gonna pee myself. I'm gonna pee myself. I'm gonna pee myself. I'm gonna pee myself.